So, have you ever been just brimming with ideas for a new project, totally ready to dive in, only to kind of hit a wall?
Oh, absolutely. Like you've got this amazing front end design, maybe.
Yeah, exactly. Beautiful, intricate app front end, but the back end services, they're just not there yet, not even close.
Right. That feeling of being stuck, just waiting on dependencies.
It's so common. But what if you didn't actually have to wait? Today, we're doing a deep dive into how one company, Ford, really revolutionized their Android development process. They had a telematics app, and they tackled this exact challenge head on.
And their solution was pretty ingenious,
Hmm.
the mock server. We're going to unpack how simulating that back-end behavior doesn't just allow for, true parallel development and faster features.
Which is huge already.
Huge. But it also leads to, like, stress-free testing and a much more collaborative team environment. It's quite something.
Okay, so yeah, collaboration, less stress. I can see how that would happen. You'll see how it reduces issues, maybe makes onboarding easier too.
Exactly. Onboarding new team members becomes, well, a breeze, frankly.
Okay, let's set the scene a bit more. Ford's telematics team,
Mm.
about 15 people, you said.
Yeah, around that size. And they hit this critical point, this classic roadblock. How do we build the user-facing stuff now when the back-end services, the APIs, are still being built?
It's a scenario I bet loads of listeners recognize, that feeling where the front end is just held hostage, waiting.
Right. But instead of just accepting that bottleneck, they asked this pivotal question. What if we could just simulate the back end?
Simulate its behavior, you mean?
Exactly. And that led directly to this mock server idea. Basically, it accurately mimics the real backend services. It intercepts the API requests
Look at app is making.
that the app makes. Yeah.
Yeah.
And then it provides these controlled, predictable responses instead of relying on the actual, maybe unfinished backend.
So if the front end team is suddenly free from waiting, they're building against these simulated endpoints.
Mhm.
What's the real shift for them day to day?
Well, the immediate impact is pretty profound. The front end team gains essentially complete independence.
Wow.
They can develop without needing access to the real endpoints, which might be unstable or just not exist yet.
Right.
And this also means testing becomes incredibly flexible, much more robust and reliable.
Mm.
But the real ingenuity, I think, the thing that makes it truly effective,
Hmm.
is that it demands really close collaboration and crystal clear communication between the front end and back end teams
To do what exactly?
to establish what they call API contracts.
Yeah.
Basically, agreeing up front what the communication between front end and back end will look like.
Okay, that makes sense. So beyond what they build, how did they build this mock server? What were the key tools? Why those choices?
Good question. They went with Kotlin, primarily for its modern syntax, its developer experience, makes the kind of easier to write, easier to maintain.
Sure. Standard for Android devs now.
Yeah. And for the server itself, they picked Creator. It's a Kotlin framework, lightweight, asynchronous, really good for building web services and APIs quickly.
Asynchronous is key here, I imagine, for speed.
Absolutely. That choice meant the mock server could be incredibly fast, responsive.
Yep.
You want it to simulate instant API calls, unless you want to add latency to mimic real-world conditions, which it can also do.
Ah, okay. So flexibility there too.
Definitely. Then they used Gradle for the build automation, which is, pretty standard in the Android world.
Right.
And the actual mock responses, just simple static JSON files. Easy to create, easy to manage. So developers can just easily pick from these predefined scenarios for any API call. Like, you want the success response, click. You want an empty state, click. Need a specific error, click. And the server just delivers the right JSON.
That's a really solid foundation.
Yeah.
But then you mentioned they took it even further, something about WebSocket simulation,
Yeah.
using Crater support for that.
Yes, that's where things get really dynamic.
What specific problem was that solving? Because WebSockets, that sounds more complex to mock.
It is, a bit. But WebSockets are often used for that real-time back-and-forth communication. Think like live map updates in their telematics app.
Okay, yeah. Constant stream of data.
Exactly. So simulating this with the mock server lets it send sequences of mock data frames, like fake location updates. And it can even handle messages from the client app.
Oh, so it's interactive.
Totally interactive. It enables message pushing right from the UI for really dynamic testing scenarios. They even built a little UI for the mock server itself.
A UI for the mock server. What for?
So developers can easily trigger actions, like request a new authentication token, simulate a disconnection, or even paste in a totally custom JSON response on the fly. Gives them full control over that mock environment.
It's pretty neat. So once this whole mock server setup was in place, how did it really change their day-to-day? How did it enable, faster features?
Well, it became just integral to their whole development cycle. It wasn't just an afterthought.
Right.
It supports this full range of scenarios, not just the happy path, all sorts of unhappy paths, different errors, handling pagination, what empty states look like.
So QA must have loved this.
Oh, yeah. It became an indispensable companion for QA, quick, isolated testing. And it massively streamlined their integration testing later on, too. But the workflow, it really starts with planning. Meticulous feature planning and, crucially, agreeing on those API contracts we talked about.
That agreement phase sounds key. Who's involved in that?
That's where front-end, back-end, and QA teams all sit down together. They define every endpoint, its expected structure, the request, the response, before anyone starts coding the real thing.
And they use something like Swagger for this, a shared space.
Exactly. It's something like Swagger.
Yeah.
The back-end teams provide those initial JSON snippets. Here's what success looks like. Here are a couple of error examples.
Okay, so the front-end team gets these JSON snippets. What then? Do we just use them as is? How does that lead to parallel work?
Ah, good point. No, they don't just copy-paste. The front-end team takes those snippets and they actively modify them. They think about all the edge cases.
Yeah.
Like, okay, what if this address string is super long? Will it break the UI layout? What if this list comes back completely empty? They harden the mocks.
Ah, okay. They make the mocks more robust than the initial examples.
Precisely. And this is how the actual parallel development kicks off. The back-end team starts building the real endpoint, maybe takes weeks. Meanwhile, the front-end team is already building their features, pointing their app at the hardened mock endpoint, completely unblocked.
That makes perfect sense. So what if they need to add a completely new endpoint to the mock server? How does a developer actually do that? Is it complicated?
No, they designed it to be really straightforward. It's basically a four-step process.
Okay.
First, you define the feature using an enum class in Kotlin. Simple names like vehicle list success, vehicle list empty, vehicle list error, states for that feature.
Got it. Step 1. Define states.
Step 2, add the mock data. You take your adjusted JSON snippets, the ones covering edge cases, and put them in a specific directory, usually named after the feature.
Okay. Step 2, add JSONs.
Step 3, implement a really simple handler function. This just connects those enum states from step 1 to the specific JSON files from step 2, tells the server which file to serve for which state.
Connects the dots. Makes sense.
Step 4, register this new route, this new endpoint within the mock server's main configuration file. Just tell Creator it exists. And finally, they update that little UI tool they built.
Ah, right. The UI tool.
Yeah, so any developer can easily see the new endpoint, manage its states, switch scenarios super easily. It's all about developer experience. And then, once any update to the mock server code adding a new endpoint, fixing a bug gets merged into its central code repository.
Yeah.
They use a Gradle plugin called the Shadow plugin. What it does, basically, is it packages everything, the mock server's Kotlin code, all the libraries it needs, like Creator, into one single self-contained executable file. It's called a JR file.
Okay, so one file to run the whole mock server.
Exactly. Super convenient.
Okay.
And this JR file is then automatically published using GitHub releases.
Right.
That publish action triggers a CI/CD job, continuous integration, continuous delivery pipeline.
Standard automation stuff.
Yep. And that job uploads the JAR file to JFrog Artifactory. Think of Artifactory as like a central library for all their internal software bits and pieces.
So it makes it easy for developers to get the latest version.
Dead simple. They just add a little custom Gradle snippet to their Android project, and it pulls down the latest mock server JAR automatically. Really streamlined.
That's a very slick deployment pipeline for the mock server itself. But how does the actual Android app, the telematics app, use this? How does it connect?
Good question. The app's own code repository has a dedicated configuration section specifically for different environments, like mock environment configuration.
It's okay, so it centralizes those settings.
Right. And in there, it includes things like the API base URL. So for production, it points to the real production server. For staging, the staging server. And for mock,
It points to localhost, where the mock server is running.
exactly, localhost plus whatever port the mock server is listening on. So a developer just flips a switch in their build configuration, rebuilds the app, and suddenly the app is talking to the mock server running on their own machine. Now, if we kind of zoom out a bit from the nuts and bolts, the real success of this whole parallel development thing, it really hinges on two absolutely non-negotiable elements.
Okay, what are they?
Shared API contracts, we talked
Mhm.
about that agreement phase, and proactive communication channels.
Right. Define and agree first.
Define, agree before code gets written.
Yeah.
And yeah, things can change, requirements evolve, but you need constant open communication between all the teams, front end, back end, QA, to manage those changes and make sure everyone stays aligned.
What did that communication actually look like day to day? Were there
Mhm.
specific meetings or tools they used, not just hoping people talk on Slack, right?
Oh yeah, much more structured. They actually institutionalized these three amigos meetings.
Three amigos.
Yeah, it's a term from agile practices. Basically, bringing together representatives from front end, back end, and QA specifically to discuss upcoming endpoints, hash out concerns, agree on the
So
details.
dedicated time for that contract negotiation.
Exactly. Plus, they had dedicated Slack channels just for specific features, so discussions were focused, and regular weekly syncs just to keep everyone on the same page overall.
Makes sense. Structure avoids things falling through the cracks.
Totally. The core principle is just crystal clear. Collaborate early, agree on those contracts, and this is important, treat the mocks as the shared source of truth.
What do you mean by shared source of truth?
It means everyone trusts the mock. If the mock says the API behaves a certain way, that's the agreement. So, for instance, if they want to test an edge case, like what happens if a vehicle name is so long it needs to wrap onto two lines in the UI, they just configure the mock to return that long name, run the app, and instantly see how the UI handles it. They don't have to wait for the backend team to implement that specific case or try to fudge data in a real environment. They trust the mock reflects the agreed contract.
That instant feedback loop must be incredibly valuable. Okay, this seems like such a natural fit for UI testing then. How did using this mock server change their approach to writing, say, espresso tests? That's the standard Android UI testing framework, right?
Yeah, Espresso's the standard, and it completely transformed their UI testing. You know, UI tests in Android can often be flaky or slow, especially if they depend on real network calls or external services.
Oh yeah, notoriously flaky sometimes.
Exactly. By using the mock server, they ensure their UI tests are super reliable, totally independent of any real backend services, and incredibly fast to run.
How do they technically hook it up? How does Espresso know to talk to the mock?
They set up a custom test runner. It's a piece of code that runs before the tests start. And this runner initializes the test environment, and importantly, it uses dependency injection.
Dependency injection.
Right.
So they swap out the real network component.
Precisely. They basically inject a special version of their network client that's configured to talk to the mock server instead of the real internet, but only when the tests are running.
Clever. So walk us through a typical UI test scenario using this setup. How does a test actually play out?
Okay, so the flow is actually quite elegant. First, the test itself programmatically starts the mock server, just runs that jar file we talked about.
Right.
Then the test tells the mock server what responses to serve up. It enqueues them, like, okay, for the next request to vehicles, send back this success JSON. For the one after that, send this error JSON.
So you pre-program the mock's behavior for the duration of that specific test.
Exactly. Then the test drives the app, clicks buttons, navigates screens. The app under test makes its network requests as normal.
But they get intercepted by the mocks.
Yep, intercepted by the mock server, which duly returns the pre-programmed responses. And finally, the test uses Espresso's assertion tools to verify the UI. Does the screen show the right data? Is the error message displayed correctly? So for a practical example, let's take that vehicle list UI test again.
Okay.
First, maybe you define an enum class just for that test. Vehicle list test scenario, success, vehicle list test scenario.emintpy, vehicle list test scenario.error.
Right, test-specific states.
Then they use something they call a mock server robot. It's just a helper class. You'd say mock server robot.set vehicle list response, vehicle list test scenario.success. It handles telling the mock server which JSON to enqueue.
Okay, so abstracting the mock server interaction.
Exactly. Then maybe a fragment robot handles the UI actions. Vehicles fragment robot.click refresh button.
Driving the UI.
And finally, a verify class or another robot checks the result. Vehicle screen verifier.verify vehicle displayed Mustang. Or if they set the error scenario, vehicle screen verifier.verify error is shown.
This whole robot pattern, it sounds incredibly powerful for making tests readable, like you're writing a story for the UI. Yeah. But does it get complex to manage all these robots?
That's the beauty of it. What's genuinely remarkable is how these robot functions let you chain everything together.
Yeah.
The mock setup, the UI actions, the verification steps, all in a highly readable, almost prose-like style within the test code.
So a test might literally read like a sentence.
Pretty much. You can write a test that effectively says, given mock server returns success when user navigates stow vehicles, then vehicles error shown. And another test right after. Given mock server returns error when user navigates stow vehicles, then error is shown.
Wow.
It makes writing these robust UI tests much easier, honestly kind of fun, and incredibly effective at catching UI bugs way before they ever get near a real user.
Okay, so after putting in all this effort, building the server, integrating it, changing workflows, refining testing, what were the actual tangible results Ford saw? Yeah. The real-world impact.
Yeah, the outcomes were pretty significant, as you'd hope. They definitely saw faster iteration cycles. Teams could just move quicker.
Makes sense.
There was a dramatic reduction in integration issues found late in the cycle because so many edge cases were being caught super early against the mocks.
Fewer, it works on my machine problems between front end and back end.
Exactly. True decoupling. The teams could work fully in parallel without stepping on each other's toes nearly as much.
And you mentioned onboarding.
Yeah, onboarding new developers became much easier. A new dev could check out the code, run the mock server, launch the app, and immediately start exploring all the different API endpoints and seeing how the UI reacts in various states without needing complex backend setup or access credentials.
That's a huge win for getting people productive quickly.
Huge. Plus, it gave them these perfectly controlled, demo-friendly builds. Product managers could see features working against predictable mock data. QA could reliably reproduce scenarios. Big wins all around.
It sounds almost like a silver bullet, but, nothing's perfect.
Yeah.
Where do they stumble? Or where do teams generally run into trouble when they try to implement something like this? What are the pitfalls?
That's a really important question. Because, yeah, it's not magic. The main challenges undoubtedly revolve around keeping those mocks in sync with the real APIs.
Yeah, okay. Drift.
Exactly. Preventing the mock data or behavior from becoming outdated as the real back end evolves. And dealing with what people sometimes call environmental drift.
What's that?
Just small, subtle differences that can creep in between the mock environment and the real staging or production environments. Maybe slightly different data formats in some edge case, different authentication nuances, maybe some complex business logic that's hard to perfectly replicate in a mock.
Right, so the mock is great, but it's not identical.
Precisely. And this raises a crucial point. While mock servers are incredibly powerful, especially for early development and UI testing, you absolutely cannot rely on them 100% for final validation.
So you still need testing against the real thing.
Absolutely. Proper end-to-end or integration testing against real APIs in a realistic environment is still crucial before you release. Mocks get you maybe 90–95% of the way there for UI behavior, but you need that final check against reality.
That makes total sense. So looking ahead for Ford, or just generally in this space, what's next? How are they evolving this strategy?
Well, one interesting thing they're investigating is creating a dedicated demo environment build of the app.
Okay.
This build would run using the mock server responses directly from that JAR file we discussed, but without needing to actually start the mock server process itself. It would just bake the responses in.
So a totally self-contained demo app.
Exactly. That would be incredibly useful for things like sales demos, where you definitely don't want to be hitting live APIs, or for making integration tests in their CI pipeline even smoother and more predictable, removing the need to manage a running mock server process during the tests.
That sounds very useful.
Anything else?
They're also actively exploring contract testing.
Contract testing, what's that? It's a more advanced technique. It's basically a way to automatically verify that the mock server and the real server always adhere to the exact same contract, the same API format, same data structures.
So it programmatically checks for that drift we talked about.
Precisely. It helps proactively prevent those subtle mismatches between the mock and the real thing, keeping them in sync automatically. It's a powerful way to build even more confidence.
Very cool. So after this whole deep dive, if you had to boil it down, what are the most important takeaways for listeners thinking about their own projects?
Okay, let's see. First, I'd say parallel development. It's not just a pipe dream. It's entirely achievable. But, and this is a big but, it absolutely demands relentless proactive communication between your teams.
Communication is paramount. Got it.
Second, treat your mocks as a critical team asset, not just some throwaway code. They should be treated as a shared, living source of truth that everyone contributes to and trusts.
Invest in them.
Absolutely. Which leads to the third point. You must invest. Invest in the right tooling, like Ford did with Krator in their UI. But maybe even more importantly, invest in cultivating the team habits, the processes, the meetings that prioritize collaboration and keep communication flowing consistently.
Tooling and habits.
Right. And finally, probably the most actionable advice. Get everyone, front end, back end, QA, maybe even product, to collaborate on those API contracts first. Hammer out the details before coding starts. The upfront investment in getting those definitions clear, it pays back massively in reduced confusion, fewer bugs, and way less rework down the line. Huge headache saver.
Collaborate on contracts first. That seems like the foundational piece for all of this. So today we really explored how this idea of a mock server, using Ford's experience as a great example, isn't just some, niche technical tool. It's actually a catalyst for fundamentally better collaboration, much faster delivery, and ultimately more reliable software.
Yeah, it really is. It empowers teams to genuinely work in parallel, to test with a level of confidence they probably didn't have before.
And to innovate without constantly being held back by those frustrating sequential dependencies that plague so many projects.
Exactly. And this whole approach, it highlights something quite profound, I think. That sometimes the biggest leaps forward in how we build software come from, well, simulating what isn't quite real yet. It lets you iterate, refine, test assumptions in a safe, controlled environment.
Turning those potential roadblocks into launch pads, essentially.
Well put, yeah.
So thinking about our listeners,
Hmm.
what does all this mean for your projects? What dependencies might be holding your team back right now? And maybe, just maybe, how could a similar approach, proactively simulating parts of your environment, unlock completely new levels of speed, sanity, and innovation for you and your team? Something to think about.